So I think that's great. I think Drew is absolutely right that asking good questions is something that we really need to focus a lot more on in this field. I think there was a slide a little while ago that Chris put up about saying that we want to train people to do is when they get data sets to do the right things with them. But I think that there's a much too large of an emphasis within the data science community on tools and on techniques at the expense of correctly framing problems and asking good questions. And I don't think that this is some magical skill that only you have if you are either born with it or maybe you go through a PhD in social sciences to get. I think this is something which other disciplines have really dealt with and have come up with good solutions in how to teach people what good questions are and how to frame their ideas in ways that will actually help things. And the disciplines that I am going to talk about today are some ideas from design and some ideas from rhetoric and some ideas from sort of heuristics of problem solving that I think are extremely relevant to how data scientists do their jobs and how data scientists can be relevant to the organizations that hire them or the problems they want to work on. And so the first thing I'm talking about a little bit is rhetoric. And when I say rhetoric, I'm not talking about the president's speech was all rhetoric as if it was some empty sayings. There's a very old discipline that falls inside philosophy and the law and a lot of areas of the humanities, which is concerned with making strong arguments and organizing our thoughts in ways that allow us to actually accomplish things with them. I mean, all of the time people are forced to handle things in the world, they're always operating under uncertainty. And this is the kind of thing that we aren't the first people to deal with uncertainty and making decisions under uncertain times. I mean, this is like a very old kind of thing. And I think arguments really get at the center of a lot of what data scientists do. I mean, some data scientists directly make arguments. Their job is to make arguments for a living. Some data scientists build tools or build products. But even if you're building tools or products, you are still making arguments all the time. You're making them to yourself. You're making them to your users. I mean, correctly thinking about and producing good arguments is part and parcel of being a good data scientist. I think this is one of those things that actually separates out data science as a field from some of the more tool or mathematically driven things in statistics, where it's more about, I have a data set, and what are the cool things I can do with that data set. I think people often jump too quickly to that kind of thing. The example I'm going to use from rhetoric, there's a whole field of this. I'm in the process of writing a book about all the things that we can learn as a field from other fields. And one of the examples I want to give is there's a thing in rhetoric that is, I think, a very useful tactic, which is called stock issues. And the idea of stock issues is you say to yourself, OK, I have some question I'm trying to answer. Let's imagine that you've already been given some kind of task. And now I want to say, what kind of question is this? And once I know what kind of question it is, then I can actually say, what are some follow-up questions I need to answer, some stock issues that I'm going to have to answer in order to do something useful with this problem that's before me. And so the typical ones, this is a formulation that goes back a very long time. This particular layout of it is probably 50, 60 years old, but it's an idea that's been around for about 2,500 years, going back into the Greeks, that you would organize these things in this way. And so just going to give a quick example, because obviously I don't have a lot of time, of what a good example of a sort of question of fact versus questions of policy would be. So fact is, turn your phones off, everyone. A question of fact is something like, how many sales did we have in each department in the last quarter? So this is like a very obvious thing. Once you make a claim about it, I know what sales are, I know what a quarter is, I know all these things, I just go and do it. Now, they can be hard things to answer. I mean, you can build models and whatnot that are designed to answer facts, but they're still, argument-wise, fairly simple arguments. I'll give an example of a more complicated kind of argument that I think data scientists are often put in the role of working on, a kind of policy argument. And I say policy, I mean helping a decision maker decide whether or not to change their behavior. And this is something which data scientists are asked to do all the time, to go investigate something and tell us how we should proceed, or is there something useful here that we can do with the data we've got. And so one example of this might be, say you're some sort of NGO, and you're trying to decide if you need to build a model to change how we allocate resources during a disaster. So the stock questions for policy are, is there a problem at all, first off? Then if there is a problem, what's to blame for this problem being the way it is? Will there be a proposal that the proposal we have actually solve the problem? And will we be better off on balance if we use this? So to go through this example of the NGO, we could say, is there a problem at all? Well, maybe the whole organization knows already there's a problem that you allocate resources poorly, but maybe there's an entire data project you have to do to actually demonstrate that you're doing this badly. Is the problem poor allocation? Maybe people are stealing things off the back of your trucks. I mean, before you go ahead and build a model, you actually have to know that there is, what the problem is, and that the problem is something which you might even be able to address. Then you have, will the proposal solve it? And this is something I think, is more kind of in the wheelhouse of where machine learning often is used, or a lot of statistical work of how robustly can we extrapolate from our data, how correctly are we going to put these things together. And that's, I think, something we already kind of know how to do. And then lastly, are we better off using this? I mean, if you build a model, but it's going to be incredibly costly to deploy, then no one's going to want it. I mean, these are the kinds of questions and the kinds of activities that people have to do in the course of putting together projects and putting together arguments that are in data science that I feel like having little tricks like this can actually be extremely useful to help us not get tangled up and so focused on immediately going to the data and the tools. So going through a little quickly now, I think there's also a lot of things we can learn from the field of design thinking, from some of the work that's been done on problem-solving heuristics. I think there's this tendency to rush to the data and to say that what we do is people give us data and we analyze it, but that's never how it actually works, right? In practice, you have some sort of vaguely defined need, and you're trying to articulate better what this, how to solve this need. And if you're actually working in an organization or you're working in academia or whatever you're doing, you're not starting with data. You're starting with some problem that usually comes to you poorly defined. It's usually handed to you as figure this thing out, or go find something fun to do with our data that's going to help us make more money, or things like, they can get really vague like that, or even things like, where should we expand to? What market should we go to next? That is not already a problem for which you can just build a model for. You have to actually figure out, what do you mean when you say market? What do you mean when you say, are we talking about timelines of 10 years, 1 year? How are we going to measure these things? These kinds of questions are questions you're not going to be able to answer if the first thing you do is go to your BI tool and immediately type in fastest growing markets in the system, and then say, okay, it's New York, go there. And if you do that, you're just not going to be useful. You're short-circuiting the process. And one of the things we can learn from the field of design is that it's very important to work backwards. Rather than starting with the data, start with the need. Do your best to articulate as best you can, in a more concrete way, what problems you're actually trying to solve, and then imagine what a solution would look like. So if I'm trying to figure out which markets to expand to, then what I'm going to end up with is some kind of ranking of the markets, and so I know already I've built something in my head of what it's going to look like. I think a really important tool that I've seen people use all the time successfully, and these aren't, by the way, these aren't things that people don't do ever, but it's useful to have some explicit thinking about them. I think it helps us be better at working with data, is making mockups. I mean, I see great data scientists all the time making little sketches of a little graph of relationships between things. So then once you've made the little sketch, you can say, oh, my x-axis is this, my y-axis is that. Now I kind of understand, oh, I hadn't even realized that I needed to control for that kind of thing. The kind of things that you only get at if you start at the end rather than starting at the beginning. And of course, you kind of work your way back and forth until eventually you meet somewhere in the middle and you've created something of real value. So, I mean, this is something I think is a conversation that I want to get started and have happening more in the community. I'm happy to chat about it with anybody who wants to talk about it. My name is Shron again, and I do data science consulting here in the city, and I'm always happy to chat. Thanks.